Okay, normally we're recording now. Um, all right, so today we're going to be talking about classes. Not this class, but a construct in many programming languages that are very, very useful. Uh, and we'll also be talking about objects. And we'll see, you're like objects. Isn't everything an object? Yes, kind of, sort of. But we'll see the specific way in which everything is an object today, as far as programming is concerned. Um, yeah. So Python, like a couple other programming languages out there, is what we call an object-oriented programming language. And all that means is that it supports classes and objects. Not all programming languages do. If you take more CS courses, you'll probably work with some that don't support that sort of thing. Generally, they're like lower level languages that don't offer this kind of convenient abstraction because they're more focused on letting you interface with the nitty-gritty hardware of your device. But Python is one of these higher level programming languages that supports object-oriented programming. Um, yeah. So what is an what is a class? What is an object? So I think maybe the best way to explain what an object is, it's like we saw how functions let us reuse actions in some sense, right? Like when we wrote a function, it was because we had this thing, we had this behavior that we wanted our program to do. And rather than rewrite it everywhere where we wanted that behavior, we could just call the function and it would execute this nice modular reusable piece of code for us, right? So if functions are like reusable actions, objects and classes are reusable things. And this will become clear as we get into the lecture today. I'm just, spitballing here. But we've actually worked with a number of objects and classes already in the course. Strings are an example of this. Lists are an example of this too. And as we'll see a little later, it turns out everything in Python is actually an object, but forget about that right now. Um, yeah, they're just reusable things. And there's no way that I can illustrate more right now without actually showing you what it is. So the best way to do this, as always, is with an example. So let's get into it. Let's write our first class in Python. So I'm going to make a new file and I'm going to call it blackjack.py. And at this point, you've seen enough games and casino stuff that you're probably wondering if I have a problem. It's not the case. I just really like this particular example. I think it's very illustrative. So remember the blackjack problem from the previous assignment, okay? If you did this or you took a look at the solution, then the way that we actually wrote it was we had this thing called a hand, right? And we were using that, basically hand in that program was a list of cards. And we represented the cards using strings with the name of each card, right? Um, but what you might notice is that there were a couple actions or functions that we did that were very closely associated with the contents of a particular hand object, right? Like one thing we were doing, one function that we wrote was this get value function that took a look at your hand and it gave you the value of that hand at a blackjack table, right? So whenever you have some data and some functionality that operates on that data, and the two are intertwined in a close way, this is a candidate for when you would want to make a class to bundle all of that data and functionality together. So what we're going to do, our first class that we're going to write is going to be a hand class, right? And this will be useful because maybe we want to modify our blackjack program to have more than one player at the table, right? And then rather than having separate lists and separate, like needing to keep track of separate lists and keeping track of the values of all of these lists separately, we can just have a single hand object that we can, a single hand class that we can instantiate for each player at the table. All right. So reusability. Yeah, let's just get into it. So the way that you define a class in Python is with the class keyword. So this is a new keyword that we're looking at. So we're going to make a new class, and I'm going to call it hand. Okay? So you notice a couple things about this. First, the naming convention for classes in Python is a little bit different from variables and functions. They use this thing called Pascal case. And this isn't necessary. You could name your class whatever you want. I'm just giving you the kind of accepted, agreed upon practice, which is whereas before we were doing snake case, and snake case looked like this. Pascal case looks like this. Or Pascal case looks like this. So you see, we're separating our words with like capitalizations of the first word in each case. And this is just like a convention. It's kind of the one that everybody follows. So, okay, we have a class, right? It's not a very good class right now because there's nothing in it. So, okay, when you have rather, I think maybe the best way to illustrate this is here is our class file, right? But at the same time, I'm gonna lecture 7. I'm gonna make a new file that I'll call blackjack tester. And this will be, well, no, I'll save that for later. We'll deal with that later. Um, so, okay, so when you have a class in Python, we want to be able to call it, right? Like ultimately, what I'm shooting for, what I want at the end of this class definition is I want to be able to do something like this. Player one, and this is like some separate code, like this isn't part of the class. I'm just writing this here to illustrate it. In fact, I should probably do this in the Python terminal. Python 3. So what I want to have at the end of this is I want to be able to say player one is equal to a new hand object and then some information about that hand. Okay? Now, you'll notice this looks like any variable assignment that we've seen so far in the course, right? But there's this special object initiation syntax that we're using here. Okay? Now, to create a new hand object, what you do is you use the assignment operator, and then you call the name of the class, and then put 2 parentheses. And this initializes a new hand object. So hand is the class, right? But player one is an object of that class. Okay. And we can have multiple objects of that class. Like if I've defined player one, then later I can have player two, and that'll be a separate hand. Okay. But yeah, this is what we want. And it'll become a little clearer as I start to write. But okay, so we need to write this function that sets up the new object. And this function in a class is called the constructor. Okay. And the syntax for that is you write def underscore underscore init. Then you pass it this thing called self. And then this is your function that sets up your class object. And I'm going to put pass here, okay? And that's just because I don't want it to do anything right now. We all remember the pass keyword from a previous lecture. It's just when you have some code block and you need to put something there, you could just put the pass keyword and it does nothing, right? So this is like at its core, all you need to have an object basically. And we can see now that let me go to lecture 7. 3. So now what I can do is I can import, I'll just import the thing that I just wrote in my Python interpreter. So from blackjack import hand. Oh, it's blackjack. Why not? Did I call it something else? Nope, I called it that. So why isn't it working? Okay, now it's working. Magic. So now let's try. We're gonna have player one is gonna have a hand. So I'm gonna set it equal to a hand. And when I print what is player one, you can see it is a hand object that belongs in the blackjack module. That's just the name of the file that we wrote at some memory address. Okay. And what this does is when I write hand parentheses, parentheses, that calls your init function that you wrote here. But you may be wondering, why does it have this special syntax? And it's because this is just the way classes are defined, right? It's called a double underscore method or a magic method. We'll see other examples of this a little later. They're also called dunder methods, double underscore, which I think is a bit of a funny name. But okay, we've seen this is it. We've written a class, we've initialized an object, and you can see, right? Like I can have another hand object, player two, and it's its own object now, right? It's another blackjack hand object at a different memory address. But as it stands right now, our hand is not particularly useful. Oh, and this is the other thing I wanted to mention. So you'll see that when I call hand here, I'm not giving it any arguments. But if you've been paying attention, you'll notice that init accepts this argument called self. What is this? So self is a special keyword in Python that you use when you're writing a new class. And it's basically just the object's way of referring to itself. And this will become clear in a moment. I just want you to know what it is right now. Um, and another point that I'll mention now is there's a special name for functions like this that we define in a class. They're called methods, right? It's just a definition. They're functions that operate on a particular instance of an object and are defined within a class. If that's the case, we call this function a method. So this is the init or constructor method. Okay, but now let's actually have our hand do something useful. Okay, so remember, we want our hand to store a list of cards, right? Okay, so how do I associate a particular piece of data with an object in my class? Well, what I can do is I can write self dot hand is equal to nothing. So what have I done here? I've created an empty list and I'm calling this self thing that I passed, right, as an argument. But all this is saying is in this particular instance of this object that you've created using your init constructor function, we are going to have a list called hand, and it is going to be empty. Okay? So now we're also going to, like, looking ahead a little bit, we're also going to want to actually store things in this list. So at the top of this file, just for our own like convenience, I'm going to define a deck that'll have like all the different types of card we can expect in our hand, right? So we'll have an ace, and I'll use single parentheses for this. So we'll have an ace, a two, right? We could also have a three, four. This isn't part of our class. This is just something that I'm doing for what we'll see later. Six, a seven, an eight. I can count. Then we'll have a nine, a 10, and a jack. It's a regular deck of cards, so there'll be a jack, a queen, and a king. All right? So yeah, this is just for reference purposes later. Now, I should be able to add things to my hand, right? It wouldn't be a very good hand or a very useful hand otherwise if all it could ever have was this empty list. Yeah? So, okay. How could I do that? Well, I can define a new method that lets me add a card to my hand, right? And I'll just do that as follows. And you'll notice the syntax looks exactly the same as any regular function definition, except we're passing this self thing each time. So I could write add card self, and we'll take an argument this time, and that argument will be the card that I actually want to add. And then in my method, I'll say, okay, self.hand, the thing that I created in my constructor, I'm going to refer to that now. And I'll say dot append, because recall, this is how we add something to a list in Python, the card. Okay? So, all right, now our hand is looking to be a little more useful. Let's see what we've written so far. So if I do this again, and I, from blackjack, import the hand. Okay. So I'm going to make a new hand object called player one. This will be player one's hand. Okay. And now I want to add a card to player one's hand. So what I'm going to do is, to do that, I'm going to use this dot notation that we've kept seeing over and over again and that I've been super evasive and sneaky about and avoided giving you an actual explanation of what it is. Well, now we can actually do that. So we're going to do player one dot. This is saying go to the player one object and get some name dot. And the name that I want here is the name of my method that I just wrote, add card. Okay. And maybe the card that we want to add is, I don't know, a three. Okay. And now I can look at what is in my hand here. You know what? I named this rather poorly. I think I'm going to call this cards, just to differentiate between the object and the list that's on the inside. So can quit now, reload this. Okay, probably shouldn't have done that right there, but hey, it is what it is. Blackjack, and then add card. Whoops, I have to actually make the object. Okay, so where we were earlier, we added the card. And now if I can access any of the names that I've defined in my class using this dot notation for this particular object. So if I want to look at the cards, I can say player one dot cards, and I can see, oh wow, it's a list that contains a three. Yeah? So yes, question.
The self thing, but is it like replacing each object in class?
Yeah, so the self thing is it is a bit confusing for people. So for all intents and purposes, when you're using a class that you've written, you ignore this self parameter, right? You'll notice I've defined a method that accepts two arguments here, but when I call this method for an object that I've created of the class, I'm only giving it one argument, okay? And this is because what's happening behind the scenes is Python is defining a function called addCard, and its first argument is the object that you created. So the player one instance here. That's what's happening behind the scenes. That's the way Python implements classes. But for our purposes as users of this class construct, all we need to know is that we just have to define self when we're writing the method, and then we ignore that parameter once we're actually invoking the method that we've written. Okay? But yeah, the only place where we would actually use self is if we want to have data associated with a particular instance of that object, because this self is a placeholder for the object. So I'm saying the cards list associated with this player one object here is empty to start, right? But okay, let's see an example of this. So now I can have player two, right? Which is also going to be a hand object. And maybe player two gets a different card. Maybe I add card, I don't know, four to player two. And now I can look, player two's list, well, okay. Player two's cards contains a four. We've created two separate objects of the same hand class that each contain their own data. These objects, though they contain different data, are following the template that we've defined in this class, right? They have an add card method, and they have something called cards inside of it, okay? That's just a list. Yeah? All right. So, cool. We've seen how to add cards, but we were doing a little more in our blackjack game that we wrote for the assignment, right? We weren't just adding cards, we were drawing cards at random from a deck. So that's another useful thing for this function or this class to be able to handle, right? Maybe I want to have some feature where instead of manually adding a card, we can write a function called draw card. And we won't accept any arguments here. But what I'll do is I'll say add a card at random to the hand and return the card that was drawn or added. So this is going to be the behavior of this method, okay? And all right, so in order to do this, you'll notice I have the word random. So right off the bat, I need to import the random module again to actually get this to behave nicely. or to get access to the functions that I want. So we're going to import random. And actually, I'll do that. The convention is that you should always define your imports at the very top of the file. Not that it matters in terms of correctness, but it's just, again, one of these conventions that we've all unanimously agreed upon and that I want you guys to be aware of. All right, so now we can implement our draw a card at random functionality. Okay, and for that, we're going to do this. We're going to say, okay, so I'm going to create a new object or just some new variable called drawn card. And that's going to be random.choice something in my deck, right? The deck thing that I just defined up here. So I'm saying randomly pick one of these things, stored as the drawn card. Okay. Now, what we can do is we can say, all right, now I need to add that card that I just drew to my internal list of the cards that I have in the hand so far. So does anyone want to take a crack at what we should write for the next line here in order to do that? Right? Because the next thing I want to do is add the drawn card to the list of cards in this hand. Yeah.
Like the same thing you did before, but instead of card, just drawn.
Exactly, right? So I'm going to write self.append or self.cards dot append the card. And you'll notice that there's like two of these dot things here, right? And that's because I'm saying, okay, go to the object self and look at its name cards, which is a list, right? And now I'm saying, go to that list and access its method called append. Because remember, lists are objects. And so this append method, or this append thing, is a method belonging to the list class. All right, now we can finally understand what it is we've actually been doing this entire time. We've been using this list.append thing that I've kept putting off forever. Okay, cool. So now the last thing that we have to do is just return what the drawn card was. Okay? Neat. So, yeah, question.
So the self-append is just a method of appending an element in a list of lists. Is that right?
So it's not a list of lists right now. It's just a list.
Okay.
Cards is like we've initialized it to just be a list right now. Append is the method for adding an object or some new object to my list that I already have so far. Yeah. Yeah, question here.
The append drawing
Oh, thanks. Yeah, that's a typo. It's funny. You were like, she left, but she was like, we're going to do the exact same thing that we did before, except this one thing. And I didn't do the one thing that you told me to. Okay, yeah, drawn card. There we go. Cool. There was another hand. Was it also about the typo? Cool. All right. So, aha. Now let's test this new method that we've just added. All right. So get out of here. And I got to close and open it every time to reload the actual. Okay. Python 3. And from. This is why I should have just had a. Like for the sake of this working example, hold on. Make a new file. Instead of doing this all in the interactive shell, I'm just going to dump it in a file that I'm going to call blackjacktester.py. And then we'll import from blackjack, import this hand thing that I just wrote. This is just to give this new module access to the name that we wrote in this other module. Okay. And then we'll have player 1 is going to be equal to hand player 2, and then we'll add, I don't know, an ace, or the thing we want to test now is this draw card thing that we just wrote. So we're going to draw a card. Okay. And we'll even because this returns the card that we drew, we can even print what the actual card that we got was. And then we could do it again, right? We can do this, draw another card. Let's see what this does. Okay. So vertical 202 lecture 7 3 blackjack tester. Okay, so what it did was it created a new hand object, and the first card that it drew was a 4, and it stored that in the list, and the second one that it drew was a 9, and it stored that in the list. But I actually let's make this a little more informative. Let's say print. Player one draws this stuff. And then each time, let's take a look at what player one's hand looks like. So print player one hand. Whoop. And using this fancy schmancy, oh no, let's just do it this way. Okay. Player one hand. Nope, nope. And then we'll actually write what the hand looks like. So for that, we're going to do self dot, or not self, player one dot cards to actually look at its cards. And I'll use the F string syntax for this. There we go. This. And then we'll just do that exact same thing again. All right, now, when I run this, if I can actually, there we go. So you can see, okay, the first thing that player one draws is a king. And after this draw, the player one hand looks like this. It's just a king, right? The next thing it draws is a six. And after that draw, it looks like a king and a six, okay? So yeah, we've added functionality for drawing a card at random, but there was another thing that we wanted, in some sense, our hand to do when we were working with it in our original blackjack problem on the assignment. Does anyone want to guess what it was? Like what other very common functionality associated with a hand we were using in our blackjack game? Yeah?
Dividing.
Yeah. That would be another really thing for a hand object to be able to do, is just tell me the value, right? So how are we going to do that? Well, oh, before we actually get into that, I'm going to put a pin in this right now. There is a way that you can pass some predefined data to your object. So maybe at the moment of creation of this, or the moment of initialization of this object, instead of manually adding a bunch of stuff, I want to be able to pass like a pre-written hand to the hand object when I create it. How can I do that? So we can modify the parameters of our constructor to say, okay, now you're also going to get some cards, right? I'll just call this some cards, or starter cards maybe. And rather than set this to an empty list now, I can say, okay, well, the default, we're going to use this like, what's it called? Optional parameter syntax that we've seen a little elsewhere in the course. So by default, this is going to get none, right? And if starter cards is none, then we'll just initialize it the way that we were doing it before. It's like you passed nothing at all, okay? But otherwise, else, self.cards is equal to the starter cards that you gave me. Okay. So now let's see how this differs. So if I launch my little interactive thing here from blackjack, import and Control L. So now maybe player one, I want to initialize it at the moment of creation with like, I don't know, a blackjack already in its hand. Yeah. So that would be like 10 and an ace would be an example of that, right? So what I can do is I can say hand and then pass it the list that I want to initialize it with of ace and then a 10. Okay? And now when I look at my player one's cards, player1.cards, I could see it was automatically populated because it wasn't none with the starter cards that I specified in my constructor. Okay? On the other hand, if I just do player two, I can still have it so that there's an empty initialization, right? Player two hand. And player two's got nothing. Okay? So yeah, we can pass arguments to constructors. Right. Now to get back into what was brought up over here earlier, we also want some functionality that lets us get the value of a hand. Okay, so let's see how to do that now. So we can define yet another method. Okay, cool. I just wanted to check my notes for this lecture real quick and see how we're doing on time. So we can make another method now, and I'll call it get value. And again, self, and we're not going to take any other arguments. And for this, what we want to do is return the sum of all the cards in our hand, right? But there's this special condition where if my hand has a value of 10 or less, then any ace that I have in the hand counts as 10 more, right? So an ace can either be a 1 or 11, and it'll be the score that is most advantageous for your hand in blackjack. Yeah? You remember this from the rules? So, okay, let's see how I can implement that. So I'll start by just summing everything in the list. So for that, I'm going to have a for loop. I'm going to say for card in self.cards. And now for each card that I see, I want to match it to some integer value. And as you could probably guess from my use of the word match here, a convenient thing to do for this, or to use for this, is a match case statement. So we'll say we're going to match card, and then we'll say in the case where it's an ace, for now, we'll just give it a 1, okay? And we actually want to store what the value of our hand is. So to start off, it'll just be 0, okay? And so in the case where it's an ace, we'll add a 1 to our value. In the case where it's a king, or I guess the next thing is a jack, right? If we're doing like the special cards first, then the value plus equals an 11. In the case where it's a queen, then value plus equals 12. And in the case where it's a king, value plus equals 13. And for any other case, right, I just want the numerical value in the name of the string. So we'll do value plus equals int of card. Okay, so this is just saying take whatever like 2, 3, 4, whatever hard-coded number you have in your string, convert it to an int, and add that to the value. Okay? All right, so we've summed the value of cards in our hand, but now we need to handle this special logic of like, is my 10, or like, do I have a hard or a soft ace, as it's called in the blackjack terminology. So to do that, I'm going to say, okay, if the value, so the first thing I need to check is if there is actually an ace in my hand, right? How can I do that? How can I do that? What operator am I going to, yeah? Exactly, right? I could just use the in operator to see if it's in my list. So if there is an ace in self.cards, and there's another condition that has to be true here. Yeah.
The value plus 10 is less than 20.
Exactly, right? And the value plus 10 is less than 21. Then I should use the 11 score of the ace and not the 1 score. So we'll just add 10 to whatever the value is, right? So this takes ace from 1 to 11. Or was it? Yeah, I think it's an 11, right? Or is it a 10? I'm forgetting the rules of blackjack now. It's 11? Yeah, okay, cool. Okay, and then we just return the value, right? So now that that's done, let's see what the heck we've just done. Yeah, question.
Like the case match, we're using the double quotation marks versus in the, when we define the depth, we use symbol.
There's no difference. I do this really annoying thing where I like flip a coin in my head to decide which one I'm going to use. But syntactically, they're the exact same thing, right? But you're right. The good convention is to pick a lane and stick to that. I don't do that, but do as I say and not as I do. Um,
Then give double with a case map, and then I write if A in self card. Does it matter if I use symbol there?
no, not at all. That's totally fine. Okay, so we can test this now and see. All right, so let's uh let's actually do this. Let's say quit. Oop. And then three from blackjack import hand. All right, so player one. Somebody shout out a favorite blackjack hand. Could be anything. What do we want in our hand? A card, anyone? Going once, going twice. Four. Let's do four. Okay. A four, uh, and a five. Except these should be strings, right? So I'm initializing a new hand object to have these things. Well, and we can check player one. Okay, well, player one dot cards. It's a four and a five. And so if I get the value of this hand, player one dot get value. Whoa, I got a nine. Cool. And now if I add, maybe I want to add like I don't know. It's currently nine, so let's add an ace. Dot add a card and an ace. Okay. So if I look at my hand now, or I look at the value of my hand now, it's what you'd expect. It's a 20, right? But if I add another card that would put it over 20, you get the point. Okay, I'm not going to belabor this. Yeah, so this is a pretty useful blackjack hand class that we've written now. All right. Now that we've seen the nitty gritty a little bit of this, or like how to actually write a class, I'm going to take a moment to wax philosophical. So why should you use classes and objects? I've already mentioned there are some programming languages that get away with not having them at all, right? So then what is the advantage of having these things? Well, there's a couple. There's a couple really compelling reasons that make object-oriented programming so ubiquitous today. The first I already kind of mentioned at the very start of the lecture, and that's code reusability, right? And next lecture, we're going to see a particularly powerful form of code reusability that classes allow you to do called inheritance. I'm not going to say much more about that right now, but I just want to put a pin in it. The second reason why classes and objects are so useful is this concept called encapsulation. And what encapsulation is, it's basically like bundling together like object and functionality on that object in a way that allows the writer of the class to control the way that data is accessed. Okay? Because oftentimes you'll notice that like we, as the user or client of this class, we could have manually added all of these cards ourselves, right? We could have just had like self. We could have bypassed all the fancy functions that we've just written and had self.cards dot append, or sorry, not self, it would be player one. Player one dot cards dot append a king. Okay. And that modifies like get value. It modifies it in the exact same way as using our add function. So like, what the heck? Why even bother doing this, right? If there's already a method that I can just call with not much more work, it saves me having to write this entire class, right? But here's the thing. We very often, as the writers of this class, we want to control the way that the data is accessed in very particular ways to avoid unintended functionality. I don't just want, because this is a blackjack hand, I don't want the user of this class to just be able to add whatever they feel like, right? As it stands, I could do this. Coconut. And then this is no longer a valid hand. We've allowed our user to mess with our data inside that we wanted to keep private in some sense. So methods let you control this. In my add card method here, I can control for the kinds of cards that I want to be stored in my hand, right? I can have something that says if card not in the deck, right? If it's not a valid card in the deck, then I can raise a value error and say, you know, attempt to add invalid card. Yeah. And so if I do, I don't know. I gotta reload this whole thing now. If I so if I have this player one object now, and I initialize it to nothing at the start, oh, it's because I didn't import it, I guess, from blackjack, import the hand. So if I have this player one object and I initialize it to an empty hand, now if I try to add something that isn't a card, like a coconut again, it says, hey, you can't do that. I am now in charge of what data is in my hand object. But if you just had the list floating out there in the wild in whatever code you were using, there would be no way to enforce this, right? So this is encapsulation. And I can, if I want to add an actual valid card, wait, oh, it's because okay, I made a mistake. It should have been add card. We were getting the wrong error. Player one.add card. And now it's value error, attempt to add an invalid card. And if I try to do this with an ace, then it's cool. Then it lets me do that. All right. So yeah, this is encapsulation. Very, very powerful concept when you're designing very large and complicated programs. This is a super useful thing to be able to do, this restriction. So that's kind of the first reason. The second reason, the first being reusability. And the third big reason that you want to use classes and objects is this idea called polymorphism. Whoa, what does that mean? And this is another one of those things that's best illustrated with an example. And to do that, we're going to make a new class. So we're going to create a class that represents a vector now. So I'm going to have a class, and I'm going to call it vector. Okay? And much like our hand, what we want to be able to do in a vector, in some sense, is store a list of coordinates. Right? I mean, that's all a vector is at the end of the day. It's just a list of numbers. Okay, when I write my init function, it's going to look suspiciously similar to the init function that we had for our hand. So I'll say, okay, we're going to have self.coordinates is equal to an empty list. Or no, maybe I want to write my vector in such a way that I can only initialize it with a non-empty vector, right? So I'll have some argument called chords, and I'll say, okay, the list. And by the way, it's okay to name these the same thing here because you'll be able to, like the Python interpreter will be able to differentiate them based on this use of the self keyword beforehand, right? Or the self name. So we'll say, okay, this allows you to initialize a vector to some list of coordinates. Cool. All right. What is something that I should be able to do with a vector? Maybe one thing I want to be able to do is get its norm, right? That's a pretty common, the norm of a vector, for those of you unfamiliar, you could just kind of think of it as the case of the L2 norm, It's just the length of the vector, right? So if I have a So if I'm just working in 2 dimensions, okay, and I have some vector that looks like 3, 4, then it'll look like, 1, 2, 3, 1, 2, 3, 4. So it'll be here. And so this is 3, this is 4, but the length of this is my norm of my vector. Okay, just linear algebra reminder for everybody. Um, so how can I do that? Well, I'll write a function called norm. And this will accept no arguments. It's just going to get back the norm of the vector that I specified in the coordinates of my constructor. So there's a way that we could do this with a for loop, but I'm going to show you a nice, convenient Pythonic way of writing this using list comprehensions, which is this thing that we keep seeing over and over again and that I encourage you to use because they're very, very nice, and we'll see why. So the way that I can do this is, first of all, mathematically, the way that we get the L2 norm is we square every single coordinate in my vector, we sum those together, and then we take the square root of all that. Okay? So let's see how I can do that in one line. So we're going to return. We're taking the sum, right? So we can use the built-in sum function that Python provides us with. The sum of a list. So it's going to be c squared for c in chords, right? So I'm defining this new list using a list comprehension that's just taking, oh, sorry, this is incorrect. You should use this. This is c squared for c in the coordinates. And then I'm going to take this entire sum and I'm going to take the square root of it. Okay? This is just for the L2 norm. Okay? Are we all clear on what this list comprehension does? Yeah? Yeah, question in the back. Oh, yeah, thanks. Thanks. That's another, thank you. 0.5. Thanks for that. Yeah.
When we use the sum function in list, like each thing Alex need to get, or
Yeah. So this is like doing a for loop for you, basically. Rather than you writing an actual for loop and saying for each thing do this, right? It's saying in one line, because the thing I want to list comprehensions create new lists from an iterable that you give it. So here I'm giving it some iterable, which is my list of coordinates, and it's going through that list, and each thing in my new list is going to be what happens before the for keyword here, right? So it's going to be c squared for every c in this list of coordinates that I already have. Make a new list, sum that new list, and then take the square root of that sum. All right, one line. Cool. So, all right, we can test that this actually works by doing what we did before, quit. And now I'm going to import this new vector object from vector, import vector, Control L. And so I'm going to have a vector v, and it'll be a new vector object that just contains the list of coordinates here for this particular silly example of 3 and 4. Okay, cool. And now when I do v.norm, aha, that's the mistake that I made. So you can't just, I can't just have chords here, right? I want to get the coordinates of this particular instance of this class that I'm working with. So I need to use the self keyword. That's what I forgot to write here. Okay. So, oh God, I need to reload the, life is hard. From vector, import, vector, neat. Okay, so v is equal to a new vector object. I'm gonna make it with 3 and 4. And then v.norm Oh, I get 5. That's what I wanted, right? Because the norm, this is like if you just do the Pythagorean theorem, you can see the length of this thing is 5. Nothing crazy, okay? So, okay, we have a norm thing. But you know what another really common thing that we want to be able to do with vectors is? We want to be able to add them, right? Like if I have two vectors, the way that I add them is I just do the component-wise sum. Yeah? It would be really cool if I could do something like this, right? So let's say I have some vector called E1, and it looks like 1, 0, or 0. Yeah, let's say 1, 0. Okay? And I have another vector E2 that looks like 0, 1. So these are just the standard basis vectors for R2, right? Like this is E1, this is E2. So if I add them, remember in vector addition, it's like we add vectors tail to tail, right? So the vector sum that I should get from this is this plus this. So I go here and then I go up 1. And so what I want their sum to be is just 1, 1, right? And it would be really cool if I could just do this. If I could say I don't know, some new vector u is equal to E1 plus E2, right? And have Python understand somehow that when I write plus here, what I mean is do vector addition. Okay? So is this even possible? Well, as it's written right now, when I do this, I get an error. I say, okay, well, there is no plus operation defined for types vector and vector. Classes let you do that. So let's see how we would actually do this. So we could say, we're going to use another magic method or double under method for this. So we're going to have def underscore underscore add self and then some other vector that we'll call v. Okay. Now, when you write plus, like I tried to do here, what Python does is it goes to this object's class vector and it checks, have they defined this special underscore underscore add underscore underscore method? And if I have, then it implements the functionality here whenever I write a plus sign. If we think back to the beginning of the course, there was a name for this. It's called operator overloading, right? From one interface, writing this plus symbol, I'm achieving the functionality that I want without needing to know or write anything more about the underlying classes. Yeah? Because it's up to the class to implement this desired behavior. So let's see how we can do this now. Okay, well, we're going to say we want to return a new vector, right? So we'll return a new vector object. Notice that I'm calling my constructor here. And what this is going to look like is, again, I can use a list comprehension to simplify this on one line. Actually, maybe I should break it down and say, okay, the sum vector is going to be equal to a new vector. And it'll be, does anyone want to try writing a list comprehension for adding two vectors together? Like, what would I put here? Using the list comprehension notation. Okay, it's a bit of a tricky one. So in the interest of time, I'll just give it to you guys. So we can say it'll be v. Yeah, sure. It'll be self.coordinates. So go to, and I'm gonna, in the interest of clarity, I'm gonna write this single line a little differently. So I'll say, okay, I'm gonna indent here. And you can indent however you want once you're inside the parentheses of a definition. Like Python doesn't really care about this. I'm just doing this for clarity, so it won't be one really messy long line. So we're going to say, okay, for self.coordinates I, it's going to be self.coordinates I plus v.coordinates I for, we can even do a new line here, for I in the range of the length of self.coordinates. Okay. Yeah. And then we need one more closing parenthesis over here. Cool. So it's just like we're iterating through the range of the length of I. So this is I is just going to be the index into the vector. That's what's getting updated. And for each index, our new vector is going to get the sum of this vector's coordinate at position I and the other vector's coordinate at position I. Yeah? And then just return that as a new vector object. Okay? This is now that we've defined this new object, I'm just going to return the sum vector. Neat. Cool. Now let's see if this actually works. And yeah, maybe the best way to do this is I can make, yeah, in the interest of time. So we'll do vector tester dot py. And we're going to say from vector import. I'm just writing a little tester script now for doing this. It'll contain what we wrote earlier. So E1 is going to be a new vector. It contains just 1 and then 0. E2 will be the other standard basis vector for R2. 0, 1. And now what I want to do is I want to print their sum. I want to say print E1 plus E2. And this should give me 1, 1, right? Their sum, assuming I've done everything correctly here. Okay, let's actually try this now. If I write Python 3, let me clear this a little messy. So Python 3, and then the name of this simple tester script that I've just written. Oh, well, okay. I actually need to, I see. So what we'll do is we'll say the sum vector, or the sum, which I'll just call V, is equal to E1 plus E2. And then we'll write print V's coordinates. Okay, so print the coordinates of V. And now once I do this, I can see I get their sum, 1, 1. I've overwritten the plus functionality using this add dunder method. Okay, and there are a whole bunch of dunder methods. For every single operator that you can think of in Python, there is some special underscore underscore method like this that allows you to overwrite its behavior and define it for your class. Okay? And we can actually, I think it'd be useful to see the actual, oh God almighty, that's not what I want. Let's take a look at some example dunder methods. So dunder methods. Oh, here we go. Every dunder method in Python. There's like a whole bunch of these, right? Like you can, if you want to define how equality works for your class, right? Maybe if you want to define equality for two operators as just checking the components that each in each vector is the same, you can write that with the underscore underscore equals dunder method. Okay. And there's comparison operators, less than, greater than as well. Type conversions and string formatting. If you want your object to print in a certain nice way, when you call the object in a format string, you can control that using underscore underscore string. Okay. And so there's all these different dunder methods, like even for things like length, right? Let's actually see another example of this. Nope, that's not where I wanted to be. So we can add another, like another useful thing to be able to do is maybe I want to be able to access individual components of my vector, right? So I want to be able to say vector and then use the indexing operator to get the first thing. Yeah? So if I run this as is, Python 3 is not happy because a vector object as it's written is not subscriptable. But I can make it subscriptable. I can have this indexing operator work as follows. I can say, okay, well, I'll define the get item dunder method, self, and it accepts some index key, right? and I'll just return the coordinate at that key position. So I'll say return self.coordinates at the key. Okay? So now when I run this, I can say, okay, yeah, I've gotten the first component in the sum because I've overwritten this get item function. Okay? So all these dunder methods, all these operators that you can overload or overwrite, they provide one seamless interface for the user of your class to work with that abstracts away all the complex functionality of like what is actually happening when I add two vectors. Okay? And this plus operator, it works for strings, as we've seen. It works for ints. Now it works for this vector object that you've written. This idea of having one interface for working with multiple different pieces of code in the background, that is polymorphism. Okay? Comes from the name many forms, right? And the cleanliness that this interface allows you to achieve in the code that you write is very, very nice. And that's what we refer to when we say writing polymorphic code or code that is polymorphic. It's this idea. Yeah. Okay. So yeah, there's a whole bunch of other dunder methods, like I said, that we could see, but I just want to make sure that I've mentioned everything here that I want to. Yeah, we could even do like len as well to get the length of, underscore underscore len. Maybe we just want to return how many coordinates self dot coordinates length and the length of this whole thing. Cool. So there we go. And now I have defined a length function, but instead of like, you'll notice that when I try and print v as is, I get this ugly thing that's like, it's telling me it's a vector object, but maybe that's not. And what it's doing is it's like Python is looking for the underscore underscore string underscore underscore method in this class. And because it's not finding it, it's just doing this default behavior of outputting this hideous string telling you what the actual object is instead of what its contents are. But I can control how my vector is converted to a string by using the underscore underscore string underscore self. And now maybe I just want to say, okay, return self.chords as a string, right? Whatever the string representation of this underlying list is, that's what I want to return. Okay? When I do this now, you can see, oh, now it's nicely printing this 1-1 thing. Yeah? So this is operator overloading. This is polymorphism. This is another very, very compelling reason to use classes and objects. I want to have like a little 10-minute break or like a brief break for people to go in the bathroom, ask me additional questions before we get into the quiz. But before we do that, are there any questions about any of what we've seen today on classes and objects? Any high-level stuff on classes, objects? Yeah, as I said, on Monday, I won't be here, but I will release a lecture recording that covers inheritance and some other stuff about names and references and modules in Python. That'll be the scope of Monday's lecture. Yeah, that's kind of the end of what I wanted to talk about for today. Yeah, so let's take like a little break. I'll relax and then we'll come back in like 10 minutes and I'll start distributing the quizzes.